So the exponent here is a 3. That tells us there's going to be 4 terms. So when I go to Pascal's triangle, I just need to go to row 4. Write out those numbers, space them out. And what am I going to have to start? I'll have 4a squared 3 times. Then I'll have 4a squared 2 times. Then 4a squared once. Next, the 2b. I'll start with none of them. Then I'll have 1 of them. Then I'll have 2 of them. And finally, I'll have 3 of them. So there's our setup. Now we just do our exponents one at a time. So 4 cubed is 64. A squared cubed, a to the 6, plus 3. 4 squared would be 16. A squared squared would be a to the 4 times 2b plus 3 times 4a squared times square this 4b squared, and finally plus 8b cubed. And then anything more you can simplify. So 3 times 2 is 6 times 16 is 96. And I have a to the 4b. 4 times 4 times 3 is 48. A squared b squared plus 8b cubed. So again, we found all 4 terms. And I guess if you didn't circle 3 and 4 from question 1, you can circle them now and also circle question number 7. And at the bottom of this page, I'm going to highlight a formula that's on your formula sheet and also explained at the bottom. And if you would like to, under that general term, if you would like to, please write, let's see if I have it, and that actually in the notes as well. Under this general term, this is the way that it's written on your formula sheet. See, k plus 1, n choose k, a to the n minus k, b to the k. What does this mean? And on your formula sheet, I think it's for, they say for a plus b to the n, not x plus y to the n. So some things to notice. The n, that's the exponent right here in the original expansion. The number that goes here is always your first term. The number that goes here is always your second term. And the k is always 1 less than the term number. Because there's a k plus 1. That's your term number. If I wanted to find term 7, well, something plus 1 equals 7. K would have to be 6. So if we go back to the example we just finished and show how this formula would apply, because what's going to happen is we're going to get, go, sneak there this way. You're going to get questions, instead of saying find it all, they'll just say, could you find term 2, which is, of course, going to be this as the answer. 96 a to the 4b. But you don't have to find them all. So how could we do this quicker? Well, we could still do the whole setup, right? You could do the whole setup and then just simplify this part. But the formula does that for us. So we're going to look how we use the formula to do this for us. Because the formula looks like this, and I'll rewrite it here. Tk plus 1 equals n choose k, a to the n minus k, b to the k. So if you wanted to find term 2, you would write term 2 equals, and that would tell you that, right, k would have to equal 1. Because in the formula, it's term k plus 1. And if the k plus 1, you want to find term 2, does it make sense that k has to be 1 less than that? And k would be 1. The n comes from the exponent. Right, so I circled that. I remember what color I used. Red. I circled. That's going to be 3. Was it red? Just make it close. Pink or red? Sure. Doesn't matter. We'll go with red. So this is going to tell me I'm going to put a 3 here. Oh, I don't want green. I want to go back to 1. 3 choose, and I already knew k was 1. This will be 3 choose 1. Okay, what's 3 choose 1? 3 choose 1 is going to be that 3. Next, the a is my first term, which is 4a squared to the 3 minus 1. Can you see that matches up with the 4a squared squared? And then what's my b, which is my 2b? The k is 1 to the 1. It matches up with that 2b in that orange box. So what the formula does is it lets you do the setup without having to write all the other ones around it. Which is kind of nice because they're sometimes going to ask you to find the 8th term in 3x minus y to the 12th. And you don't want to write all 13 of them out. Plus, you also don't want to go all the way down to your 13th row of Pascal's triangle. So the combinations finds that right away. So the formula itself is breaking down the pattern we noticed so you can find it quick. And then you can simplify from there. Okay, so I'll stop this video and then we'll use the formula.